Alright, hello, welcome to this video lesson for CPI 111. In this lesson we're going to learn how to create the building blocks for a new kind of game. It's a sort of maze game. It's like a top-down style game where you've got characters working their way through a maze. This assignment that's going to go with this lesson is one that's focused not so much on development, but more on game design, and I'll go over all the information you need to know about the assignment in class. In this video lesson, I'm going to focus on the technical pieces, introducing you to some new kinds of functionality in GameMaker that you will need to make use of to create this game. First, I'll give you a quick demo of what the game looks like. Alright, here's the completed version of the game with multiple levels. I'll actually give you the project that contains this completed version, and you'll use it to design your own new custom levels, one easy level, one medium level, and one hard level. And again, I'll give details in class, but just to show you what it looks like, you come in and you've got three different little koala bears that you need to get through this maze. You'll note that they move in a very unusual way, and we'll show you how to do that. That's what's going to be in this video. You have to get them all out of the room. If even one of them gets killed, then the level restarts. You can move back and forth between different levels in the game using the keyboard, and then there's a end room. For this video lesson, we are not going to cover everything you need to build the complete game. We're just going to focus on the key new pieces in GameMaker that we've not covered yet in class. For this lesson, you'll want to download a project that is on the Blackboard site for the class. It is called, in the version I'm using in this lesson, Maze Class Starter. It may have a slightly different name than that when you go to download it. But look in the Blackboard site and look for the Maze Class Starter or something similar project. Download it and then import it into a new project inside GameMaker. So this Maze Class Starter project does a whole lot of nothing, but it gets us where we need to be to start off understanding how to get multiple characters to move following a pathway inside a maze. Alright, how do we go about doing that? If you look in here, we've got some sprites. We've got a player sprite that's origins in the upper left hand corner. It's just a little red box. Got a wall sprite that does a whole lot of nothing. We have a button sprite that also does a whole lot of nothing. And we've got a door sprite that also does a whole lot of nothing. Okay, so let's take a look at the objects. We've got a wall object that also doesn't do much. It's solid, like the walls in our Click the Fruit game, but other than that, it has no events on it. And we have our door object. It doesn't do anything. In fact, it's not even solid. And similarly, our button object doesn't do anything. Our exit, I should say. And our button object doesn't do anything either. Okay. I do want you to notice one thing, however. Up to this point in class, I've not really talked about the use of parent and child objects. So here's a new concept that we'll make use of in this project, and then we'll make use of in some of the other upcoming projects, and that you are likely to use in your own games as you develop things. The idea of a parent and child object in GameMaker or in other programming languages is, at its most basic, the idea that you can create an object and designate it as a parent, and then create another object and designate that object as a child of the parent. And what will happen is the child of that parent object can inherit all of the characteristics of the parent if you want them to. Also, the child of that parent object can inherit some of the characteristics of the parent and then can have its own modified version of those characteristics or some completely new characteristics, just like in real life with people. The value of having parent and child objects inside GameMaker is that you'll often run into scenarios where you want to have a lot of different objects that act in similar but not identical ways. For example, the fruit object that we had, the apple and banana and all of that, in our fruit clicker game, those actually would have been really great candidates for being in a parent and child relationship. We could have had a single parent fruit object, and that parent fruit object would be set up to move around the screen at some random direction and to bounce off the walls and to be able to be clicked on. Then we could have created other fruit objects, set them to be children of the parent fruit object, and without having to write any code on the children fruit objects, they would have automatically done all the same things that their parents had done. So it would have saved us a little effort. So we're going to make use of that concept here. And the parent object in this game is going to be the wall object. And what we're going to do is we're going to make other objects be children of the wall. And the wall, as you see here, doesn't do anything, right? All it does is just sit there, but it is solid. And so what we're going to do in this simple example of using parent and children is that we're going to make the door object be a child of the parent object. So in effect, the door object will act just like a wall. What that means, essentially, is that when we put our player into the game and the player runs up and collides with the wall, it'll stop them. And if the player goes up and collides with the door, it'll also stop them. But we won't have to write script to check if the player's running into the door and if the player's running into the wall. We can just write some code to check when the player runs into the wall, and it will work for the door also. We're also going to make the player object be a child of the wall, and I'll show you how that works here in just a moment. All right, let's go ahead and create our player object. All right, we'll right-click resources, and as always, create an object. We will call it obj underscore player. And we will select the red player sprite. And now watch this. So we talked about in this lesson the idea of parent and child objects, and I want this player to be a child of the wall, and I'll show you why in just a minute. So in order to make an object the child of another object, you come and go to the section in the properties for that object where it says parent, and then choose which object you want to be the parent. We want the parent to be the wall, and just like that, now this player object is the child of the wall. Now we want to move the player object through the room using either the arrow keys or the WASD keys. And I think, let's see, for this we'll go ahead and use the, well, I think we've got it set up automatically to be either the WASD keys or the arrow keys. So we're going to have it move in a very particular way. As you saw in the finished version of the koala game, we had multiple koala inside the maze, and they would move down essentially the sort of hallways of the maze, and they would all move simultaneously. When you moved one of them, all the rest of them would move as well, and they would get stuck if they ran into a wall. But there's even more than that going on inside this movement. The way we want the player to move in this maze game is that if the human playing the game presses, for example, the down arrow or the S key on their keyboard. We want the koala to start moving downward and then continue moving even if the player releases or stops pressing any keys. Continue moving until that koala and any koala that are inside the room have moved completely from one invisible cell in the grid to the next invisible cell in the grid. What do I mean by that? Well, let's take a look at the room inside our maze starter project. So in the maze starter project, you can see that we've got all of the wall objects already placed in here. And we already have the hallways placed in here. Each of these wall objects, and in fact, each of the objects inside the game, all of the objects, are all 40 pixels by 40 pixels. And if I want to position them within a 40 pixel by 40 pixel grid, I can help myself out by selecting the down arrow on this snap to grid option in the room, modifying the grid X and grid Y to be 40 by 40, which is the size of our object. So now you can see that there are these lines set up in a grid, each of them 40 pixels by 40 pixels, and our game objects fit perfectly within those slots. One more thing to notice related to that is that for the sprites in this game, I have the origin point for all of them set in the upper left-hand corner. Having it set in the upper left-hand corner makes things easy when I want to snap them into those cells inside the room. So what do I mean by that? Well, let's say I wanted to add another piece of wall here. Okay, first make sure I've got the instances selected, and in fact here I've got multiple layers, so let's see which layer the walls are on. They're on this first layer here. So I'm going to grab not the sprite, but grab the object for the wall, and when I come to drag it out, you'll see, oh wait a minute, it doesn't look like it's setting up right. Well, why is that? Well, in your room you can set different grid dimensions for each layer in the room. So we set 40 by 40 for this grid layer, which is great. We'll use that for things like the exit and the little button here. But here on this layer we have the wall objects, and if we want to position those on a 40 by 40 grid, we can also change the dimensions of that snap to grid, and now when we drag an instance out, you'll see now it nicely snaps into each of those cells in the 40 by 40 grid. All right. So the way we want things to move within this grid, as I mentioned, is that if the player, for example, let's say we had a player object sitting right here, and the human playing the game presses the down key, we want the player to begin moving downward and continue moving downward even if the player stops pressing any direction keys until it has reached and snapped into the next available open cell. If they press the down key again, keeps moving until it reaches the next available cell and then stops moving. So let me show you how we can set that up. Open up our player object, and we're going to take care of all of our movement for this player inside the step event. So create a step event, and just a regular old step event. Then here's what we're going to do. We only want the human to be able to impact the movement of one of the players, one of the koalas ultimately, if that player object is fully snapped into a cell. And if it's fully snapped into one of those 40 by 40 pixel cells, then they'll be able to move it and have it move toward the next cell. If the player object is in process, meaning it's underway, it's moving already between one cell and the next cell, we're not going to let the human control the movement. They have to essentially wait until the player object has reached and snapped into the next available cell. So to prevent the human, the person playing the game, from controlling those koala, the player objects, unless they're snapped into a specific cell, we can say if not, and this exclamation mark means not. Okay? If not, and I'm going to use a built-in method or function called place snapped. And I just said the idea is that we want to check to see if the player object has snapped into one of those 40 pixel by 40 pixel cells. We can use this place snapped to achieve that check. We pass it the dimensions of the square or the cell that we want to check. I guess it doesn't have to be a square. And what we're going to say is this: if the player object is not snapped into a 40 pixel by 40 pixel cell in the room, then exit. And what this word exit means is just what it sounds like. It means we're going to completely leave this step event and do nothing else. Right? So if this condition is true, and by true it means that the player object is not snapped into one of those 40 by 40 pixel cells, then we're just going to quit this script and not do anything. So assuming this isn't true, then we'll do whatever follows in the upcoming lines. Well, what do we want to do? Every time a player object is snapped within one of those 40 pixel by 40 pixel cells, we want it to stop moving. So the player initially starts it moving, it works its way to the next cell. When it reaches the next cell, we need to tell it to stop. And we can do that using some built-in variables that we've used in our fruit game. We're going to set the V speed to 0, and we'll set the H speed to 0 as well. So we're snapped into a cell, so stop moving. That's what this will do. And when we get into the koala game, we don't have to do this yet, but I'll give you a little preview. In the koala game, we're going to be using sprites for our koala character, for that player character, that will change their appearance based on whether the koala is standing still, moving down screen, up screen, left, or right. And so when we get to that point, what we would want to do if the koala is stopped is to show a sprite that demonstrates the koala not moving. We don't have that here, but I'll put it in here in a comment using these double forward slashes to show you what we'll end up doing in the real game. We can use this built-in function called sprite index, and that will allow us to choose a sprite to associate with our object. And when the player is stopped in our koala game, we're going to make use of a sprite in there called koala stand. Okay, again, this is just a preview for what's coming up. We don't have to do that here because we only have one player sprite. All right, so fine. So we've made our player, in this case just this red square, stop moving. Now that it stopped moving, it's at this point that the player is able to then cause the player object, the humans, able to make the player object move up, down, left, or right. So let's start by figuring out what we need to do if we want the player to move down. Okay. Well, we can make use of a piece of built-in functionality, a built-in function that we used with the Dragon game called keyboard check. And if we want to check if the player, the human, is pressing the down key, then we will use vk_down. So if the player is pressing the down key, what do we want to have happen? Oh, well, the simplest thing to do, and one that won't quite work correctly, is the following. We want to move down screen, right? So what we can do is set the V speed to whatever it is now, which is 0 at the moment, plus 5, right? And to do that, we have to use a special bit of coding called plus equals 5. And that will cause it to move 5 pixels faster than what it's doing at the moment down screen. Okay? And we'll set the H speed equal to 0. And you might wonder, why do we have to do that since it's already set to 0 here? Well, the idea is it's possible that the player will press like the down key and then press the right key. And if they press the right key, it's going to alter the H speed. And so then when they press the down key, we need to reset that speed back to 0. Okay? Okay. Now I said this won't work. And that's not 100% true. It would kind of work. So let me show you what I mean by kind of working. So if we start our game now, you remember I've got the player object sitting out there in our maze. Here's our player object. If I press the down key, hey, look at there, it moves and it goes to the next cell, next cell, next cell. Everything's looking good. And you'll note what I'm doing in the background is I hit the down arrow and then it just moves by itself until it hits the next spot. But watch what happens here. I'm up against the wall, but uh-oh, I can keep going, and in fact I can go right out of the room. So this sort of works, but we need to detect when there is a collision between the player and the wall. So how can we do that? Up until now, what we've used is the built-in collision event, but that doesn't really make sense here, right? We're within a check of the keyboard, and then within that check, we need to also check if we are colliding with a wall. So if, I even said it, we need to check if we're colliding with the wall. And to do that, we can use another built-in function called place meeting. And place meeting works this way. Basically, in the background, GameMaker is going to take the object that this place meeting function is hooked to, in this case the player object, and it's going to move it invisibly behind the scenes into whichever position you tell it to move to, and then it will check to see if there's a collision in that location with some other object that you specify. Right? So in our case, we want to move down screen, since we're doing down, and we want to check if there is something down screen of where we're at. Well, where exactly do we want to check down screen? Well, remember that we're moving our character basically 40 pixels at a time. They press the down arrow, it's going to move into the next 40 pixel cell and then stop. So we want to check 40 pixels down screen from where we're at the moment. And to do that, X, I want to check X, which is just neither left nor right of where we're at, just right where we are going across the screen. And for the Y, I want to check our current Y position plus 40 pixels, meaning 40 pixels below where we are right now on the screen. Then I need to say, what object is it I want to look for? What is it that I want to see if I'm going to run into? And the thing I want to check is if I'm running into a wall. Okay. Now we've got this if statement here, so just to clean things up, we're going to move this over here, these braces. So we've got the outer if that's checking if the player presses the down key, and then we have this nested if statement that checks if they are going to run into a wall object 40 pixels below where we're at, then move. That's sort of exactly the opposite of what we want, right? If there's a wall 40 pixels below us, we don't want to move, right? We don't want to let them move. So just like up here where we use this exclamation mark to mean not, we'll do the same thing here. If we are not going to run into a wall 40 pixels below where we're sitting now, then go ahead and move. Excellent. So that will work. And let me demo it really quickly. It also helps to explain a little bit about why we're going to make, or why we did make this player object be the child of a wall. So first of all, here I am. I'm moving. If I hold down the key, I can keep moving. And look, I hit the wall, so I stop. I won't keep moving. So I said that this will help explain why we made the player a child of the wall, and I can demonstrate that really quickly. Let's go back into our room and make sure we have selected the layer that has the player on it. I can turn it on and off. Oh, it's not that layer, it's this layer. And if I grab another instance of this player object and put it right here, and let's grab a third one and put it right here. Now watch what happens. Because we made the player object the child of a wall, the player object will inherit the properties of the wall. And the only property of the wall is that it's solid and it's a wall. So what does that mean? It means that if we move down screen, our first player now has hit the wall and it's going to stop. But the other two haven't hit a wall, so they can keep moving. But when the next one comes down, it's now up against another player. But as far as it's concerned, that other player object is a wall, and so it'll stop moving. This prevents our player objects from moving inside each other, because as far as each one is concerned, all the other player objects are just walls. All right. Now with this basic piece of code in place, this first if check, we can go ahead and quickly do up, left, and right. So go ahead and do that, and I'll paste mine in here too. Try it, see if you can do it without looking at my code. So hit pause on your video and attempt to write all this in and then come back. All right, welcome back. Did you get it? I'll leave it up here on the screen momentarily, and so either you can copy it if you haven't had a chance to try it out yourself, or if you're running into problems, you can double check with the code I've got here. But it works. So now with our all these different ifs checks for the down, up, left, and right, we come back into the game. Now our players will move appropriately up, down, left, and right. They won't run into one another, but they can move all the way through the maze. All right, here in this maze, it's not really a game, but this maze lesson, I want to show you a couple other things that will be useful in the koala game, and then we'll do sort of more advanced version of these in the koala game itself. First of all, I want to make it so that when the player runs into this button object, it will cause the door to open. And the way it's going to cause the door to open is basically destroy the door. So let's open up the button object. And in the button object, I'll go ahead and create a collision here with the player. And what do we want to do inside the collision event? This is one that we've done before, so I won't spend a ton of time on it. We want to destroy the door, okay? So if we want to destroy the door, well, here in this collision, there's no door involved, right? There's the button and the player. So to destroy the door, we can use the keyword with, which we've used before, but before we did it using the word other, right? In collisions, which means destroy the player. Well, we don't want to destroy the player. But we can pass in the name of any object inside the room and we'll destroy that. So the one we want to destroy is object lock blue. I'm sorry, that's not the name of it. That's the name of it when we get into the koala game. Here it's called Object Door. Hey. And then we'll say instance destroy. And we'll destroy the door. All right. Now, there's a very, very important note about using this with and passing it the name of an object. When we use this as a way to destroy an instance, what will happen is that GameMaker will destroy every instance in the room that has this name, not just one. So let me demonstrate what that looks like. We come into our room, and let's see, I've got to remember which layer our doors are on, or here. Looks like we have our doors on the same layer as the wall. So I'm going to grab another door object, and I'll put one, say, right here. Now watch what happens when I hit play. I bring my players down, I come over, I hit that button, boom, and both of the doors disappear. For the koala game, this is no problem. In fact, this is the way we want things to work. Later on in other assignments, we will use a different approach in order to destroy just a single instance of an object rather than destroy all of the ones. But we'll get into that later. But it's important that you know that that's how this is working here. Last thing I want to show here is when the player reaches the exit, I want the player to leave the room. In the koala game, we're going to do, we'll do a collection of things to make this work. Here we'll just do a really simple one. We're just going to do a collision between the exit and the player. And here we'll say with other instance destroy. Now, let's make things confusing. Here, I'm saying with, again, and I'm passing other. And if you follow what I said a minute ago, it means it should destroy all of the player objects that are in the room, but it won't. And the reason it won't is that this keyword other is not addressing all of the player objects in the room. It's addressing the specific instance that we've run into here. So it will destroy only the one that runs into it. So as the last piece, let's take a look and see what that looks like. So I bring my players down. Let's unlock the doors. This guy comes up. Boom, he disappears. Boom, he disappears. And boom, he disappears. All right, that's it for this maze lesson. We'll make use of all of these pieces when we go into the koala game, and we'll add a few other slightly more advanced things inside the koala game to help our game look and act better than this. All right.